Welcome to this video on the headshot method, a technique for circular magnetization in magnetic particle inspection, or MPI. This method is used to induce a circular magnetic field within a cylindrical component by passing an axial current through it. The core principle is simple. Passing a high electric current directly through a component generates a perpendicular magnetic field. This field forms continuous circles around the component's exterior, hence the name circular magnetization method. When a longitudinal defect acts as a physical barrier to this circular magnetic field, it forces the field out of the material. This creates a localized magnetic flux leakage at the surface, which strongly attracts magnetic particles, forming a visible indication. The operational workflow involves 4 steps. First, clamp the specimen tightly. Second, pulse a high electric current lengthwise through the part. Third, apply dry or wet magnetic particles to the surface. Finally, visualize the highly visible diagnostic indications formed by the particle accumulation at defects. A critical aspect is the defect orientation matrix. The headshot method is optimized for detectable flaws that run parallel to the axis, like longitudinal cracks and seams, because they intersect the circular field. Transverse cracks are undetectable as they run parallel to the field. This technique is widely adopted in aerospace and manufacturing for inspecting long, cylindrical components. Ideal applications include aircraft engine shafts, landing gear components, heavy-duty bolts, and industrial axles and rods, where longitudinal stress fractures are a primary failure mode. Operational advantages include generating an exceptionally strong magnetic field and high efficiency for cylindrical components, detecting fine longitudinal surface cracks. However, a strict limitation is its unsuitability for transverse cracks, and poor contact can cause dangerous localized heating or electrical arcing. In summary, the headshot method passes current lengthwise to produce a circular magnetic field, detecting longitudinal surface and subsurface cracks. Primary applications are aircraft shafts and similar components. Remember the critical risk. Ensure perfect contact between the component and copper heads to prevent high current arcing.